All right. Hello everyone. Welcome to IT Pro Dev 2020, and especially in my session for monitoring with application insights, focusing on a microservices design pattern. As I already said, my name is Vassilis Salis. I'm a cloud solution architect working for Microsoft, and my day-to-day is on the partners ecosystem of Microsoft and especially the independent software vendors. Some contact details of mine, you can see them on the slide, my email, my LinkedIn profile, and my GitHub account as well, where you can find all the repositories that I have shared. There are not many. This is quite new for me, but you can find everything that we're going to see today and a couple of more things as well. So let's get to it. Before we start, I'd like to say that this is a deep dive session in terms that I'm not going to focus on details of the various services that we're going to see. I take into consideration that you already are a bit familiar with application insights, with Azure functions, with Azure Web Apps, with Azure Kubernetes Service, because all these things we are going to use them on the demo. Most of the time of this session is going to be around the demo, showcasing how you can use application insights to monitor a microservice design pattern and run that either in the platform as a service flavor of Azure or in a Kubernetes cluster on AKS, on Azure Kubernetes service. So we're going to set really that I'm going to use for a demonstration and then move right to into the demo. All right, so for those of you that haven't heard about application insights, I hope that you have. However, it's an application performance management solution run on Azure. Actually, you can integrate application insights with pretty much all the popular frameworks, the popular languages like, of course, the Microsoft ecosystem, Java, Python, PHP, all the major languages are supported, and there's this SDK that you can use in your code to actually use application insights. And of course, the control plane of that is on Azure. You can have different application insight instances for different application of yours, where you can see the actual telemetry that is being collected from your application. In that part, I would like to focus on the distributed tracing that application insight supports. So this is pretty much the core of this demo. On a microservice design pattern, you have the need to be able to track a request from all the routes and all the different components of your solution that passes through. And this is exactly where we're going to focus on the demo. And of course, application insights supports that out of the box for specific service, of course, but especially for .NET Core and the demo that we're going to see, it's supported pretty much out of the box. You can also use distributed tracing of application insights with all the other major popular frameworks. In some, it's pretty much supported out of the box. In some others, you might need to have to write a couple of lines of code. It's you can actually do the same things in all the supported languages. And of course, application insights is part of the Azure Monitor feature. So some of the things that they are not first-class citizens of application insights that can be found on Azure Monitor typically. All right, so the demo that we're going to see is a solution that parts of three microservices. One is called the Alerts microservice. The second one is the Device microservice. Different domains. The one in theory takes care of the alerts domain. The devices one takes care of the device's business domain, and one third microservice, which is called back office, that in theory would communicate with the other two, the alerts and devices, and do some background operations. So in front of these microservices, I have used an API gateway using the Ocelot library to forward the requests to the different components. And you can see on the slide that these things, they're going to be deployed on either a web app or Azure functions, but at the same time we're going to deploy them also on AKS. So a rough application, a rough architectural diagram of this solution is this. As you can see, in front we have the API gateway, which on the PaaS version is going to run on an app service, and this communicates with the two microservices, devices and alerts. And then as a message bus, I'm using service bus in order for these three microservices to communicate together. Actually, alerts is not communicating with devices, it's just alerts and devices via or through the service bus. They're communicating with the back office microservice. And each of these microservices has its own persistent layer. So the first one is using a SQL database, the second one a Cosmos DB, and the third one an Azure table storage.
All right, so let's get started with a demo. But before we do that, let's have a quick look at a couple of libraries and frameworks that I used for my solution. So the first one is the Ocelot. The Ocelot is an open source .NET Core API gateway, and I have used it to implement the API gateway of my solution. On top of that, I have used the Poly library, which is a .NET library to implement policies such as retry, circuit breaker, timeout. These are pretty common policies in the microservices design pattern implementation, and I'm going to focus especially on the circuit breaker design pattern. For those of you that don't know this pattern, what it means is that, what it states is that when your piece of code, when your microservice, for example, is trying to call another third-party system or another microservice, and this third-party service is either failing or responding too slowly. In theory, it's better to fail fast and stop calling this API, stop calling this third-party service, instead for your application to, for your solution, so for your microservice, to be waiting for that service to reply, or to wait for the service to fail. I mean, if you know that the service is going to fail, why bother calling, right? Because this usually results in a domino effect where this problematic, let's say, part of the solution is starting causing problem to other pieces of the solution as well. So the idea is that fail fast, and whenever you have a new request in that, slowly try to see if, you know, by pinging this third-party service, if it's back on, right, and then return to normal operation. And in this case, if the caller, for example, the front end or your user interface knows how to handle this situation, provides usually a better user experience. So besides these two libraries, you can find pretty interesting things, I hope for. I hope so. In my GitHub repository where I'm hosting this demo, you can find all the code that is needed, and also pretty cool GitHub actions with the continuous integration, continuous deployment scripts that I'm using for the deployment. So the exact same solution is going to be deployed with these scripts to both the platform as a service flavor using web apps and app service, and on Azure functions on a consumption based profile. And at the same time, it's going to be deployed on a Kubernetes cluster, an AKS cluster that I'm running. So the exact same solution, the exact same code is being deployed in two different infrastructures. And in this demo, what we're going to do is with application insights, see how this thing operates, and how we can see what's going on, and how these microservices are communicating, and what's going on in that place. So enough with the introduction about that. Let me fire up my Visual Studio. All the things that we're going to see, and actually the implementation that I have done is using the Visual Studio. This is my ID of preference, but this doesn't mean that you have to do it on the same ID. You can have the exact same demo in different languages, for example, Java, Node.js, all the languages that they're supported by Application Insights. You can have the exact same solution implemented using different code editors, different IDs, and different languages. So the solution that I have for this demo is part of 4 projects. The first project is a .NET Core web API that is implementing the API gateway using the Ocelot framework that we already said. And this API gateway for the platform as a service flavor, it's going to run on a web app that's going to be hosted on an app service on Azure. The same goes with the Alerts microservice. So the Alert microservice, the second project here, is a .NET Core web API project as well, which is going to be hosted on a web app as well. And actually, it's going to use the same app service as the API gateway. The other 2 microservices, the back office one and the devices one, these are Azure functions, and they're going to be hosted on the platform as a service version, on the PaaS version, on the consumption based for function. Now, all these 4 projects, for the AKS versions, they're going to be containerized, and they're going to run within an AKS cluster. Exactly the same solution. The only thing that is changing are the configuration part and the environment variables. And actually, this is the way that I have used in order to differentiate the configurations between the 2 flavors, between PaaS and AKS. So the code doesn't really know where it's hosted. I mean, if you take into consideration that all of these projects, they could be plain old Docker images that they're spawned into Docker containers, right? It really doesn't make any difference where this container is running. So as long as the container has access where it needs to have access and has the configuration that is telling that container that, look, this is where the database is located, and everything in between is configured properly, then it doesn't make difference if the container runs on an app service or it runs on AKS, right? So let's have a quick look at the code, and let's start focusing on application insights, because this is what is actually the demo about. The infrastructure is pretty much irrelevant, and this is what this demo is trying to showcase, that if you are using application insights, and especially the SDK, it really doesn't make any difference where your code is going to run. So for the .NET Core application, for the API gateway, the only thing that I have done this part is the references, of course, of application insights, Ocelot, using the provider for Poly, and also I have used Serilog, but I could have omitted that and wouldn't make any difference, to be honest. So let's see how the Ocelot is being configured. Actually, it's pretty easy. It's just one liner, pretty much. Services.add Ocelot and add Poly. The reason why I'm needing the add Poly part is because I'm going to implement the quality of service feature of Ocelot, which is actually a circuit breaker design pattern. And for application insights, the only thing that's needed is the add application insights telemetry after installing, after having the reference to the NuGet package of application insights. This is the only thing that's needed. And on top of that, in order to configure the Ocelot and application insights, we are loading in a specific way the configuration part and also the app settings one. And here, what is really key is this thing here, right? So the configuration is a function, let's say, of the environment that this solution is hosted. So really simply, if you have a look at the configuration here, you'll see that there is a configuration.production on AKS and also production on Azure. So production on Azure is the platform as a service flavor, is the hosted in the web app and app service part, and this is for the Kubernetes cluster. Let's have a really quick look of how the Ocelot routes configuration occur. So it's pretty straightforward actually, right? This means that whenever somebody calls the root URL of where the API gateway is hosted and is using the /devices URL, then Ocelot needs to route this request to this URL here. This URL here is going to be the public facing URL of the devices microservice. And the /devices is going to be forwarded to /API/devices in this URL. Again, this is just for demo purposes. In a real life situation, I wouldn't expose this publicly, and I would have done other things in order for just the API gateway to be able and call this URL. But for the sake of the example that and the demo that we're trying to do, pretty much coverage. And the same way I could do, the HTTP post that whenever a new device needs to be added, just call API /add new device on this URL where the device microservice is hosted. Last but not least, let's have a quick look at the circuit breaker implementation. So this is the quality of service option for Ocelot, and what it says that whenever someone is calling the alerts URL and there are 3 consecutive exceptions in a row, or whenever the service response takes more than 1.5 seconds to respond, then the circuit breaker should open for 10 seconds. So for this period of time, no requests are going to be executed here. After this period passes, then the circuit breaker is going to be half open and try a couple of requests. And if they are successful, then it's going to close and get back to proper and normal behavior. So this is pretty straightforward about API gateway. And just focusing again on application insights, the only thing that is needed in order to have the distributed tracing, the out-of-the-box telemetry for dependencies, requests, is this, right? With this thing, if this solution was communicating with service bus, or if it was communicating with a SQL server or something like that, it would be depicted immediately and out of the box on application inside. And this is exactly the same case with the alerts microservice. So the alerts microservice is using again the application insights NuGet library, and again initializing it at some point. It's using the add application insights telemetry. This is it. And also this microservice as a persistent layer is using an Azure SQL database, and this is again configured here, right? And again, what is really important is that how the SQL server in Azure is being configured, right? You can see that the configuration, it just needs a connection string. So this means that this connection string, it could be an environment variable, or it could be on app settings. It's exactly the same. You can actually choose if it's going to be on app settings or it's going to be on environment variable. For me, I find it easier to use environment variables because I could have the exact same approach on hosting the web app. On the configuration part, we're going to have a look at that when we see the Azure Portal, or when you spawn a container within a pod within AKS, it could be passed as an environment variable to that container. Now, to be honest, especially for connection strings, this is not a best practice. This is a bad practice. I shouldn't have connection strings in configuration, either on app settings or environment variables. I should have used more secure features, more secure services, and in this case, it would be Azure Key Vault. This is what I need to do but for the sake of this demo, I have omitted that part. But in a real life situation and a production system, you wouldn't want to use this part. You would not want to use Azure Key Vault in that part. All right, so this is pretty much it for the alerts microservice. I mean, for the sake of the demo, it's pretty simple. The only thing that it does is that on HTTP GET, it's just communicating with the database, and it's just returning all the alerts that it has there. And at the same time, again, for the sake of the demo, it's broadcasting a message on service bus, right? Because usually microservices, they have to have a common message bus in order to communicate with each other. So in this case, the idea is that something happened in the alerts microservice, and it needs to inform all the other microservices that they are interested in that. So this is just by broadcasting a message on a service bus topic, and whoever subscriber is subscribed to that topic, they can accumulate the message and do the business logic of their own. So HTTP GET for alerts does exactly that. It's broadcasting a new message, and it's returning all the alerts from the database. Now, for again the sake of the demo, as a quick and dirty solution, if the database doesn't have any alerts, I'm populating the database with just a few alerts, so there are some data there. So these two first projects, they're going to be hosted on web apps on platform as a service offering of Azure. The other two, they are Azure Functions, and they are hosted on the Azure Functions serverless infrastructure. And actually, I'm using the consumption-based profile, which means that the infrastructure is purely serverless, and it's defined by its own how many services it should instantiate to run that code. So the devices microservice, it's pretty much the same logic as the alerts. It's implementing an REST API that is using as persistent layer the Cosmos DB, and whenever there's the HTTP an HTTP trigger here for the functions, whenever there's an HTTP GET verb, it queries the Cosmos DB and just returns the first top 100 devices. Pretty straightforward. And after that is broadcasting that message to service bus. Again, this doesn't make sense. I mean, usually in a GET function, you don't inform other services as well. You usually do that whenever there's a post request that a new device needs to be added. So I added the device as a microservice on having a business of my own, and I need to inform other microservices that a new device has been added to do their own business logic. However, for the sake of the demo, whenever there's a GET in alerts and devices, I am broadcasting a message on service bus. And these messages on the service bus, they're consumed by the microservice of the back office. So this microservice, as an Azure functions, the only thing that it does, actually this is the project with the less lines of code compared to all the other. The only thing that it has is this part here, right? So this means that this Azure function is using a service bus trigger on a specific topic, and when it returns, it's actually using an outbound binding of Azure functions on an Azure storage on a table on Azure storage, right? And it's using that as a persistent layer just to write the logs and so on. So this is the only thing that it does. Now, the tricky part here for the Azure functions, and this is pretty interesting as well, is that you need to do a couple of things in order to have application insights running on its best, running on using all the features that it has. So let's have a really quick look at the GET function that we have here, right? So if you have a look at this interface, the iLogger interface, this is the way that we use in Azure Function to do our login, right? So if you go to Azure Portal and you start creating an Azure function, at some point the user interface is going to ask you, would you like to implement to have application insights on top of Azure functions? If you select yes, then the Azure function, wherever it's going to be hosted, it's going to be seamlessly integrated with this application insight instance that you configured in the user interface. So when this situation occurs, when you have that case, then whenever you are using the iLogger object here, it's actually writing to application insights. So I could use this log object to do my tracing, to do my error logging, and so on, without having to have a reference on the application insights library on Azure Functions, right? But so if you have a look at the dependencies that I'm using, I'm actually using application insights here. And the reason is that if you don't use the SDK, the NuGet package on the Azure function, and the dependency injection also for Azure functions, you don't get the fully blown functionality of application insights. So you wouldn't see end-to-end tracing and distributed tracing, for example, with Service Bus. You need to have the NuGet package of application insights, and at the same time, on the startup part, you need to have the dependency injection configuration. Otherwise, you will see logs, you will see error logging and the tracing and all these beautiful things, but you're not going to see end-to-end tracing. And in some cases, I'm not really sure if you're going to see the dependencies as well. Dependencies are usually easier, especially if it's HTTP in the middle. But in order to get the full-blown flavor of application insights, you need to have these two things for Azure functions. The first one is, as I said, having the NuGet package of application insights, and the second one is having the dependency injection part. So, as you know, Azure functions, they can be hosted either on a consumption-based plan, when you're pretty much paying for what it's being executed, with some, prerequisites there and some special conditions, but I wouldn't like to get into that right now. The second option is to use, instead of the serverless infrastructure, you can use an actual app service running on below that, hosting your Azure function. And the third option is to containerize that function and have it running wherever you can run a Docker container. So in my part, I'm going to run these Azure functions on my Azure Kubernetes service cluster, right? In that case, I wouldn't have the option to use application insights if I was not using the NuGet library and the dependency injection. I have that using the app service and the consumption-based plan, but I wouldn't have that run it in a container in my own infrastructure, and especially AKS. All right, so this is pretty much the code, the different pieces of my solution. Now let's switch back to the browser and have a look at the Azure part of things, at the Azure Portal part of things. So let me start, first of all, by the common, let's say, components of its version, right? So, for example, I'm using a container registry. This is shared between the PaaS version and also the AKS one. This is where I'm holding the four images, the four repositories. If you have a look, I have 4 repositories, one for API gateway, alerts, back office, and devices. And also at the same time, I have the service bus, which is common. I have different topics for AKS and the platform as a service version, and all the databases. This is the Cosmos DB, this is the Azure SQL database, and this is the storage table service that I'm using. And finally, I have a virtual machine running just to have my Jmeter load test to simulate the actual load. Let me show you really quickly the VM that I'm using. So this is pretty much it. You can see that it's actually running right now. I have four requests that I'm running. These are the URLs for alerts, get devices in both platform as a service and the AKS part. And in the summary report, you can see the errors that I'm having in each one and so on. Let me switch back to the browser. So I'll start first with the platform as a service version. So let's go quickly and have a quick look of what's going on. So as I said, we have a web app that's hosting the API gateway. We have a web app that is hosting the alerts microservice. And we have two Azure functions, one for the devices and one for the back office. Now, for each of these components, for each of these projects, each of these microservices and the API gateway, I am using different application insight instances. And in this case, this is the best practice for that. I'll explain in just a minute what I mean. So first of all, let's have a quick look at the API gateway application insights. One note here is that the alerts web app and the API gateway web app, they are both running on the same app service. I could have used different app services, but in this example, I just use the same. And also, let me really quickly show you this. I have used an autoscale alert rule, which is pretty aggressive, the rule that I have used. So the idea is that, all right. So the idea is that when I start having load in my system, I like it to increase really fast. So I have an alert here that whenever there's above 20% for 5 minutes, spawn me 4 new web apps, for new VMs that are going to host my solution. And scale down really slowly, right? So whenever the CPU is below 70%, take out one node at a time. It's pretty aggressive, and in a real life situation, I wouldn't use such a low limit for the CPU, but it's usually good practice when you have like bursts and spikes to have more than one node being added every time if you are aiming to a good quality of service to the end users. All right, so let's have a quick look at what's going on. In the meantime, you'll see, I don't know if you managed to have a look at the remote desktop that I'm sending here, is that I am simulating 100 concurrent users right now. We have requests for 100 users. So let me switch back here. So this is the application insight instance for the API gateway running on a platform as a service. Let's go to Live Metrics. So in Live Metrics, application insights, it's picking up all the servers that they are running my application, and they are having this application insights run with them. So you see that I have 10 servers online, right? This is the max version of the max node count that my app service is holding. And these are the servers that they are actually handling requests right now. I can see some sample telemetry here, the request rate, the duration, the failure rate, dependency call duration, and so on. And this is pretty cool. This is actually showing that the scale up, the scale out rules that I have used, they have been enforced. And right now I have reached the full capacity of my application in that part. All right, so let's switch to application map. And in that part, now that application map of application insights is showing all the components that they have been used, right? So you see that I have the API gateway here, and I can see the 10 instances that we saw. I also see the alerts. They have 10 instances as well. Remember that they are on the same app service. So this way they are using exactly the same servers right now for the last hour that is. And these two microservices, the devices and the alerts, they're being communicated with the back office microservice. And the back office is running to an Azure table. Alerts are writing on a SQL database, and devices are communicating with Cosmos DB, right? Pretty cool, right? Now, let me really quickly go to the alerts part, or let's go to devices. It's, I think, let's have a quick look at the same thing, right? Because devices, if you remember, it's running on Azure Functions, on a consumption-based plan. And these are right now 25 servers, right? And I haven't done anything to that part. I didn't tell anywhere that you need to spawn 25 servers. This is something that the serverless infrastructure has done for me, right? So again, I'm seeing the same things, right? The dependency call duration, the traces, and so on. Let's go again to the application map, and let me try and show you what is really important in that part. So you see, in the beginning, it just says that the devices, they are communicating with a service bus. Now that I have updated the map components, and each of these instances we are seeing is on a different application inside instance, right? Imagine that I had the same application inside instance for all of these components. Then in the live metrics part, I would have the aggregation of all the servers that they are running. So I would have 10 for API gateway and alerts. I would have 25 plus, so 35, and also what would be on the back office as well. So I would have like 50 or 60 servers running my code. It would be, it's not a bad thing, but it's really difficult to filter things and see what's going on. And at the same time, you wouldn't have this great application map here. You would have only one circle with saying like 50 servers and like a loopback in that part. Right now, what I'm seeing in this implementation is that I have requests starting on API gateway, which is the front door, let's say, of my application. This API gateway is communicating with the alerts microservice, and the devices one. You can see how many calls they took place, right? And this is a direct call because this is actually an HTTP call from the API gateway to the two microservice alerts and devices. However, what is pretty cool, and this is the distributed tracing. This is the out-of-the-box, let's say, distributed tracing that Application Insights provides. The alerts and the devices microservice, they're communicating with the back office microservice via service bus. You see here this icon here. I don't know if it's easy to scale it up. This means that the communication took place via service bus, right? I'm not seeing service bus anywhere in this application map, but the application insights has correlated this telemetry, and it shows me that this microservice is communicating with this one using the service bus, via the service bus. And the same things happens with the alerts. And of course, I have these beautiful dependencies, right, that the alerts, they are communicating with Azure SQL database. These are how many calls took place the last 1 hour. This was the mean time, the average time of response for from that database. And in the same sense, the back office microservice is using an Azure table right here. These are the number of calls and so on. So this is pretty amazing, and this is for me an application map that is pretty cool and shows you from, let's say, 20,000 feet what's going on in your application, right? So the only thing that I'm seeing is that I have a 3% errors, that part. Pretty cool, right? So in the same direction, let's now switch from the platform as a service to the AKS one. So here exactly I have the same thing as well. So instead of having 4 different components running my code, I have only one, which is the AKS cluster, right? And in this cluster, I have also enabled the monitoring part. The monitoring part is an add-on, let's say on the Kubernetes cluster, that it gives you this beautiful feature right here, the insights. So whenever you enable this component, this add-on, what you're getting is actually information about the cluster itself, right? CPU of the nodes, memory of the nodes, what's going on with the containers. It's something that is, you can see that it has 2 features that they are in preview. It's something that Corp is heavily investing on, and you're going to see new features as time goes by. And for example, you can see all the containers that they are running. For example, these are the devices containers, the back office one, the application gateway, and so on. This is exactly the same infrastructure, the same wirings as we saw in the platform as a service version. If I go to the API gateway, this is again a different application insight instance, and also have different application insight instances for each service. If I go to live metrics, as I did before, I would see in that part, as we had with the PowerShell here, I would expect to see 2 versions of API gateway, 2 of alerts, and so on. So this is what I'm seeing right now. These are the 2 servers online. These are the 2 pods running my service. And again, I'm seeing the CPU, the requests, dependencies, and so on. And in the same way, if I go to alerts, for example, and I go to live metrics, I would expect again to see 2 pods running, right? So there you see 2 servers running. These are CPUs, memories, and so on. All the things that you expect to see. And again, application map. Now you see before I click on the update map here, you see that these 2 instances, they are communicating as a dependency with the SQL Server and also with Service Bus. And in this case, you are actually seeing the Service Bus service. But if I click on Update Map Components, it's going to put together all the telemetry and the distributed tracing, and it's going to show me this beautiful image, right? This is the API gateway, devices, alerts, back office, Service Bus in the middle, SQL Server, Cosmos DB, SQL Server, Azure Storage. This is pretty much the same image, the same thing that we had with the platform as a service version.
Just before we finish our session, I would like to get a bit more details on the distributed tracing. So let's have a quick look at the transaction certs. I'm going to depict the data for the last 4 hours, the oldest first, and I'd like to have a look at a successful request, right? So I'm going to choose this one, the first one that I showed, right? So this gives me the end-to-end transaction, and if you saw how it started and the other things that it populated, right now I am on the alerts microservice. However, I'm seeing that the call started from API gateway, and then it went to MS alerts. It communicated with the database, and then it passed the message to the message bus. Now, due to sampling, I'm not getting all the info in my hand. Let's try another one and see if I'm getting more information. Great, so this is the one. So as you see, here there's also available telemetry in the other parts of my solution as well. So besides, after the message bus, after the service bus, this request, it spent some time in the queue, actually 174 milliseconds, and then it went to the back office microservice, and then it went to the storage of the back office microservice. So as you can see, we have this end-to-end distributed tracing, and I can see where the request started from the API gateway to alerts to service bus, how much time it spent in the queue, and then it was consumed by the back office microservice. So with this part here, I think that I covered pretty much whatever I needed to showcase. I hope that you enjoyed it, and thank you so much for your attendance. Thank you. Take care.